that equation. So that was a long question number 5. Let's go on to 6. For the protons labeled HA and HB, predict the characteristics of their signals in the H&MR spectrum, the approximate chemical shift, the splitting pattern, and also the integration value. This is a 2-part question again. Let me write down this structure. I'm going to use different colors for these different hydrogens. So for HA, I'll use blue. And then for HB, use black. And what they're also missing here is that we can also draw in that there are more HBs over here on that side, and there are also other hydrogens here that are chemically equivalent to HA. So if we were to look at the chemical shifting of like methyl hydrogens in like a chart, you'll see their approximate chemical shift is 1 ppm for CH3. And then if we look at the splitting, if we follow the rule where it's n+1, depending on how many neighbors you have. So for HA, you'll see there are 2 neighbors beside it, so 2 HBs. So if we do n+1, you'll get a triplet as the splitting. And then lastly, for the integration value, there are 6 HAs present, so therefore its integration is 6H. Now let's look at HB. If you look up the approximate chemical shift for CH2s, it's around 1.3 ppm. So you can just get that off like a table. If you look at the number of neighbors it has, there are 3 of the HAs, and then we're going to do n+1 again. So it'll split as a quartet. And then if we were to do the integration, it would be 4H, since there are 4 HBs. So let's look at part B of this question, which asks how many unique H&MR signals exist in the spectrum of the following compound. So I'm going to draw out this benzene ring, and you'll see that there is a chlorine group, and then also there is a methyl group up there. So we already know that these 3 hydrogens will be different from the hydrogens in the ring. I'm gonna draw all of them in different colors. There's a hydrogen there that is right beside a methyl group. So therefore it's chemically different than the hydrogen beside it, which will also be different to the hydrogen para of the CH3, but also closer to this chlorine group. And then this hydrogen would also be chemically different from all of the other hydrogens because it is the closest to the chlorine. So counting out all these different hydrogens, we have 1, 2, 3, 4, 5. So therefore, there are 5 unique NMR signals. Okay, so let's see the answer from our junior tutor. Okay, so they also noted that the hydrogens here would have the same signals as H and B. They have 1 ppm for HA, split as a triplet, 6H. 1.6 ppm, quartet, 4H. Maybe they just looked at a different table. I'll just make a note of that. And then they also counted out 5 unique HNMR signals. So solution is correct. But the chemical shift of CH2 can be 1.3 ppm. I'm just going to say this solution is correct though, because all the work was correct.